So, good morning, everyone. Thank you for being here. So, the panel of today is focused on what is the state of art of civil defense on UAS. We are going to discuss about duality. What does it mean, duality? It means how systems, aerospace system, aircraft system, what is all made for aeronautics, could be used in civil, but also in defense. Just think about that since some years ago, defense and civil sector were quite divided. Military and defense has its own project in developing and realization, and the civil has the same. So what is going to we have, for instance, based on the drone strategy from the European Community? Well, we have this serving, this objective, this scope to, in certain sense, to overlap sectoring. So civil and defense, should we go together in developing the new system, the innovating system we will have in the future? The panel of today will be divided in two rounds, let's say. In the first round, we will have key messages from the defense, the Italian defense, which means the Italian Army, the Italian Navy, the Italian Air Force. And then we will have also, in the same first round, what is the state of art of the civil industry sector, which means propulsion, systems, and other structures. Then there will be a second little round, which will give us the possibility to understand which are the future. So what we are going to. To help us understand much better, I will call here on this floor, on this stage, some of my very pleasure guests, and I will begin to call the Colonel Ivan Leonardo Pagliara from the Commander Marister Italian Navy, the Colonel Alfredo Russo from the Commander of the 31st IMINT Codegons Regiment Italian Army, the Colonel Giuseppe Urbano, Director of AirPass Center of Excellence from the Amendola site, Italian Air Force Army, Mr. Paolo Salvetti, Head of Turboprop Sales from Avioaria, Mr. Nicola Gallo from Leonardo, which is the Senior Leader R&D Engineer, and then Mr. Francesco Schettini, which is the Chief Officer Operator, Sky Eye System. So, thank you all for being here. This is your remote control for. So, what we are going to do is to have some idea of what is the state of art of today of civil and defense, and then we're going to have a future key messages. So, just to begin, I'm going to call the Colonel Pagliara to have a key message from the Italian Navy, and I will leave the floor.
All right. I think we need to switch the slide presentation. That's the Air Force One. Unless we want
di Navy, la presentazione per quanto riguarda la Marina. Colonnello Pagliara. Just a few minutes from the directory. These are the beautiful things happening during the real life. So, thank you.
Thank you. Thank you for having me introducing this panel. And first of all, I want to explain why I'm representing the Italian Navy here on this floor today. I'm the commanding officer of Maristai Grottaglie, which means Naval Air Station Grottaglie. We like acronyms in the Italian Navy. So I'm a resident of the airport since Grottaglie, Maristare Grottaglie is a big portion of the airfield itself. It's about 1/3 of the airfield. And as the commanding officer of the Naval Air Station, I'm the wing commander of two squadrons, two old-fashioned squadrons. We fly helicopters and jets, fifth-generation jets, and the first series of a helicopter that is completely fly-by-wire, so very modern, but still we need pilots on board. Now, Grottaglie is the first naval air station in Italy that has started recently, only 6 months ago, with unmanned aircrafts. That's why I'm here on the stage today. And we are the latecomers, trust me. I'm very, very confident with manned aircraft, and I still don't know how to manage the unmanned. The colleagues that will follow me on the stage, they started well before us. It took a long time to get there because it's very complex to operate unmanned aircraft on board of the ships. You don't have only to design, project, build, and certify the unmanned aircraft. You also have to integrate that aircraft on board of a ship. It takes a long time. So we finally started, and we started with the Scan Eagle, Boeing Scan Eagle. It's a small, lightweight aircraft. It's 25 kilograms unmanned aircraft. Oops, let me go back. So that's it. It's very small. You can find it in our stand in the back. And right now we just have one ship that is able to operate this aircraft. This is the frigate Bergamini. We will have another one coming. It should be frigate Alpino. And maybe by the end of 2025, we will have 4 ships that will be able to operate those aircraft on board. Not that many, but we just started. And so this guy is sitting here on that chair. He's the one in charge of this small unit. So I'm privileged to be in charge of this unit here in Grottaglie. And we started a long time ago. A long time ago, we finally got there. Another project is this one, and you can find it. There's a Leonardo stand that is showing this aircraft. It's very different. The other one was a fixed wing, very lightweight. This is much bigger. It's 250 kilograms. It's a small helicopter, so rotary winged. And again, it's taking quite a lot of time to have the aircraft certified, and then it will take time to integrate the aircraft on board of the ship. Believe it or not, the first landing of this aircraft on board of an Italian ship, it was done on my ship when I was the commander of IDS Fasan. So I'm honored that they landed on my ship a few years ago. It was in 2019. And we're keeping finger crossed. Maybe we will be able to host those aircrafts on board in 2025. So still a long to come. I don't have any more slides because the other things we're looking at are very little unmanned aircrafts, and some of them are in the stands, so I don't want to give any false hope because we didn't decide what we're going to get, but we're looking to the VTOL aircraft, so small fixed-wing aircraft, but that are able to land and take off vertically. So simple aircrafts in order to increase rapidly the number of unmanned aircraft on board of the ships, because you can see how the geostrategic scenario is evolving. We need we need more aircraft to carry out intelligence, reconnaissance, and surveillance missions, which are the primary missions that these aircrafts are able to do. Basically, Scan Eagle, Hero Plus, the VTOL, this is a test bench. We just started, and we will see, we will learn what we will need in the future. And that's going to be the second part of my speech. I'm done, 5 minutes maybe.
Sure.
So, okay, so I did good.
Thank you. So thank you. So this is the way what the Italian Navy is going to have, how is operating, working, and what we saw. I just wrote down some simple points. We saw rotary wing, fixed wing, simple aircraft should just be more flexible and more fast in the operation. Now I would like to understand which is the state of art of the Italian Army. So I'm going to call on the floor the Colonel Russo.
Good morning, everyone. Thank you for the invitation. This is the first time that the Italian Army takes part to this important event. So it's a pleasure for me and for the Army to be here with you. Again, thank you for the invitation. My name is Alfredo Russo, and I am the commander of 41esimo Reggimento IMINT Coordinates. IMINT means Imagery Intelligence. And my unit provides ISAR capabilities in order to support combat units. So our main business is to perform reconnaissance and surveillance by integrated ground system and air vehicles, air system, UAVs. But my regiment is focused on a specific segment of UAV, micro and mini. So we are speaking about devices below 20 kilograms, 20-25 kilograms maximum takeoff weight. So I wanted to start my presentation looking at what happens in the world, and in particular in Europe, because we are closely studying, analyzing the lesson learned came from the Ukrainian. And in fact, the conflict, the Russia-Ukraine conflict, can be defined. Well, the main analysts define the conflict the first true large-scale drone war, due to the mass employment of drones down to the lowest level, the various classes and types of drones employed in the conflict, but mainly the overgrowth, the overgrowth of commercial drones, light, cheap, adaptable. Just the commercial drones are changing the capabilities of combat unit. And in this context, we believe that in the next future, a small device will ensure capabilities that now are related to high classes of UAVs. And for this reason, we have to change the perspective of the use of UAVs, micro and mini, from ISR functions, moving to other function, a wide spectrum of function. In fact, as you can see in the slide, in the conflict, the micro and mini UAVs are employed for a wide spectrum of tasks, military tasks, starting from traditional ISAR, moving to a lot of activity, lethal strike, finding and disposal, mine and finding and disposal, support to special forces, up to providing data to be used in the following influence activity and propaganda. so to reach efforts in cognitive dimension. So for this reason, you can understand that the UAV now is a complex device that able to reach efforts, to reach objectives in the battlespace. What the Army are doing? We are testing new function to use UAV micro and mini. In particular, starting from obviously ISR activities, but now we are testing the use of UAVs also for automatic target recognition and designation, because this is for us very important. The fact that we want to reduce the time to take the fire order to a shooter. So we want to reduce what we call the sensor to shooter cycle. We want to reduce the kill chain, and we want to improve the responsiveness of our troops. And another thing that I want to underline is the fact that we are testing the possibility to share the services that UAVs provided. And I mean micro mini UAVs. And for example, in the battlefield, if someone wants, if authorized, obviously, wants to take the control of the payloads of the UAVs, you can imagine that this is an important benefit for our troops. And if you image the deployment of a big mass of micro mini UAVs, you can imagine that what type of multiplayer role have this UAV today in the battlefield.
So, thank you to the Colonel Russo, which gave us a shot, an instant shot of what is right now the state of the Italian Army, and some key points we can stress are the integration of the systems, how drones are changing the operation possibilities and capabilities, and also how drones and technology in some case can assess some other sectors, some other dimension, such as the cognitive dimension, since the colonel speaks about the propaganda things. Another point we want to understand much more is what is right now the state of art in the Italy Air Force, the Italian Air Force. And so for this reason, I will leave the floor to the Colonel Urbano.
Thank you, Michele. Good morning to all civilian and military authorities, and welcome also to our students that were before, okay, which are the one to shape our future. I'm Colonel Giuseppe Urbano, and director of the Hard Pass Center of Excellence, which is located in Amendola Air Force Base. And this is our establishment. The center is an Italian Air Force center of subject matter expert with joint value. Means that in our agency, we do have Army personnel, Navy personnel, Italian Air Force personnel, and also Carabinieri personnel. So we work, in order to enhance interoperability and to promote what? Okay, to promote and to announce what is for us the training and standardization, and to support the capability development in the UAS sector. And before we move forward, I would like to show you this slide in order to have a common wording on what we're going to look at afterwards. First of all, this is a national classification for the drones. We are talking about a classification based on weight, So for anything below 20 kilograms empty takeoff weight, we talk about micro and mini systems. And for anything above 20 kilograms empty takeoff weight, we talk about light, tactical, and strategic systems. And why I do underline this separation between these two areas, it is because of the training. When we talk about the training, as far as training is concerned, the minimum training for anything below 20 kilograms empty takeoff weight, okay, we do require this kind of training. First of all, our customers are all services and all civilians agency, institutional agencies. So I'm speaking about Army, Navy, Air Force, Carabinieri. We do have also, as well, Red Cross, Civil Protection, Secret Service Agency, and any institutional agencies. And what we do provide, it is a course for all these trans agencies. And we do basically a course for mini micro operators, which lasts about 4 weeks. And we do provide the general knowledge, and we do provide flight skills. And when we speak about the general knowledge, we talk about regulations, flight skills, flight rules, also maintenance, aerodynamic, cartography, navigation, mission planning, specific operational risk assessment, all this kind of stuff. And after these 4 weeks of training, where we do general knowledge and handling, flight skills, okay, these operators, they will move within their own entities in order to get the specialization on their own system. Because each entities, each services, they have their own systems. And this is about the minimum training for anything below 20 kilograms empty takeoff weight. Now let's have a look when we move above 20 kilograms. When we move about 20 kilograms in Italy, okay, you must be either military pilot or helicopter pilot. So now the qualification level in order to operate any systems above 20 kilograms is much more demanding. You must be a pilot. You must be either a pilot or a helicopter pilot. And this is basically the prerequisite in order to have access to RPA above 20 kilograms. So you are a military pilot or a helicopter pilot, you come within the Center of Excellence, okay, and you receive now another course, which is a fundamental course, a 2 weeks course, in order to get the minimum knowledge to move afterwards to fly MQ-9 for the Air Force or the Shadow 200 for the Army. Those are the two only kind of aircraft we do have today within the Italian defense. Okay, so we had a look on training and standardization. So now we're going to have a look on how we do support the capability development of the UAS sector, a manned aircraft system sector. Okay, so what we do is support the writing of concept, policy, doctrine, concept of operation, and TTP, tactics, techniques, and procedures. We also ensure the national participation to any international meetings within NATO, within EU, or any international ones. We do monitor the market for any emerging technology. We do assess operational trend, and we do also provide some kind of experimentation. And in order to give you a better understanding on what we do within these areas, I will give you some case study in some of these areas. So the first case study, as far as the capability development and supporting this area, it is the Euromail. The Euromail, it is a project between 4 nations. We do have Germany, Spain, France, and Italy. And Airbus Germany is the main contractor, is the main contractor. The contracting authority, And Leonardo, for us, for Italy, it is the subcontractor. What we did here in this project years ago was, within the stage one, it was to ensure the right requirements, the right operational requirements. So we provided the common requirements from Italy in order to have the common view with all the four nations, the participating nation, in order to set what was the operational requirements to build this new plane, this new European drone. And right now we are contributing in participating in 2 working groups where we talk about the human and technological aspects, and also we focus on human factor aspects. One more case study when we talk about capability development and supporting the national industry, it is about the Sky High system Rapier X-25, which is deployed right behind you, here outside. And this plane, this drone, it is a 24.99 max takeoff weight. So it is classified within mining, the mining category. And what you see in this picture, it is basically the layout of the concept. We do have a pilot and a sensor operator operating in this, what we call ground control station. We have 2 antennas controlling the airplane and controlling the launcher. And the launcher, it is a catapult, where we do have 2 operators, 2 technicians operating the launch. And the aircraft is going to be launched through a ramp, and they will land through a parachute, normally for a normal landing with a parachute. And what we did here, supporting a Sky High system, it was support them in the reviewing of the pubs, testing the operation. We also participate in an exercise that was taken last year in a Yuma, in a Yuma base. It was an army base in Arizona, where we did experiment this drone, using this drone in order to enhance interoperability with the other services up there. And right now we are conducting the operational test and evaluation with our command and control station, which is the one that you see here, and which is the one that you can see right outside the stand, which is a mobile command and control station. Inside, we do have the ground control station. This is another kind of case study where we are experimenting a drop. I think the Regia must click on the slide, on the video, just to show the drop. Can you click? Okay. Okay, and this was just experimenting the drop of an object with a mini drone. This it is another kind of experiment, of a testing that we did. This testing was performed together with the National Aerospace Medicine Institute of Milan and the University of Milan, in order to check the effect of the flight of a drone, with a drone, of biological samples. In this case, it was blood. So what we did was transporting blood, okay, with a small drone, in order to see how the vibration, how the altitude, how the velocity may affect the blood when we transport blood. So we did this experiment. We are actually conducting this experiment. It is going on. There are some more steps that we're going to do with them, with these 2 entities, in order to keep experimenting the effect on transporting biological samples. Now, we move now toward another area, which is the other face of the coin. And we are talking about the counter-UAS sector. So what I'm speaking about is counteracting, okay, is supporting the counter-UAS capability development, meaning counteracting the threat coming from enemy drones. So what we do in this area, it is supporting the testing of this system. And we do have one just outside here, which is a detecting system. And we basically evaluate all the aspects. We evaluate all the aspects of the kill change, from the detection, identification, tracking, soft kill, and hard kill. And what we do here is provide the red teaming. So as a center of excellence for RPAS system, we can provide a red teaming, so a team that is basically behaving as an enemy. And we can be, in this behavior, we can be cooperative, so we coordinate with the team, with the counter-UAS team that is testing the system. We can be cooperative, so we tell where are we coming from, which altitude are we flying, which speed are we flying, but we can be non-cooperative, which is going to be much difficult for the counter-UAS equipment to detect us. And so in this way, we can support the industry to develop this system and test and evaluate the effectiveness of especially the detection and identification. And those are some examples of systems that we have been testing and evaluating so far. If you come us to visit in Amendola Air Force Base, you're going to have a look on our center. This is our laboratory where we basically build our own drones. And why we do this? Because we want to be unknown. When we provide the red teaming, if we use commercial drones, frequencies are known, the drone is known, all the technical stuff is known. Here we do build our own drone. Nobody knows the frequency we use, okay, the velocity is we're going to fly. So we basically provide an unknown threat for the counter-UAS system, and will be much more difficult for the industry, to build something that is going to be effective. So in order to conclude, okay, what I did was to present the Center of Excellence in Amendola Air Force Base for the RPAS system. And so we do promote standardization, training, and we do support the capability development of the UAS sector and counter-UAS sector. How we do that? Through training, supporting the concept, policy and doctrine, through field studies, through system developments, operational test evaluation, and experimentation. And afterwards, we're going to have a look on what is the UAS trends. So thank you for your attention. If you have any questions, I'm open to any.
Sure.
Thank you.
Thank you so much, Colonel. Thank you so much, really. It was an inspiring pitch, and some key points we can stress about are, of course, you saw a lot of systems and technologies. The Rapier system, for instance, or the Aeromail, some case studies, but what I would like to stress much more is the training. I think training is also something which, in a society, such our society, knowledge society, training is important. And so you see how our Italian Air Force is also working on that, on young people, on young generation to have much more knowledge about. And also, another key point is the interoperability of system and whatever. So these are the states of art, what is the defense. Now I would like to understand how industry is relating to the defense. And for instance, speaking about propulsion or system propulsion, whatever, engine for aircraft or for unmanned system, how, for instance, Avio Aero is behaving or is going to, which are the projects, which are the scope, aim, working as Avio Aero, working on civil, but also in defense sector. And so I just call on the stage Mr. Paolo Salvetti from Aero Avio. Thank you.
Grazie, Michele. Buongiorno a tutti. Good morning, everyone. My name is Paolo Salvetti, and I'm the head of turboprop sales at Avio Aero. And I'm very pleased to open the second portion of this panel, in which the industry we're going to give their view on what we are doing in terms of technology development, dual-use technology development, supporting both civil and military applications, also in response to the operational need that our armed forces have just shown to us. So Avio Aero is a GE Aerospace company which design, produce, and maintain engine parts and system for civil and military engine for aircraft and helicopters. We are founded in 1908, and we are 5,700 people based in Italy, Torino, Rivalta, Brindisi, Pomigliano, major sites, as well as in Poland and in Czech Republic. And our priority has always been to develop technologies for the next generation of propulsion system to sustain civil and military sustainable aviation. So just to explain what the industry is doing, and we as propulsion system are doing in the frame of technologies which are suited for civil and military, I just want to bring you our experience on the Catalyst. Catalyst is our next generation of turboprop engine with a power class between 900 and 1500 short horsepower that we design, produce, and certify in Avio Aero, as well as in the other GE Aerospace site across Europe. So this engine is a new centerline engine design. Actually, is the newest and the only new centerline turboprop engine design over the last 15 years, which is intended for the business and general aviation. For those of you which know this business and generation market segment, realize the fact that this market is fully dominated by one single engine maker, which is Pratt & Whitney Canada. They own like 75% of the market share, which is pretty high, right? So the only way to enter this market is not at all to offer an incremental change in performance, but you must offer a step change in performance. Otherwise, the market will never accept you. And in order to offer a step change in performance, the only way is through technologies. And this is what the Catalyst is about. And that's why I selected that motto you can see over there. The Catalyst is differentiating over the competition through technologies. So I'm talking about state-of-the-art compressor, which offer a record-breaking of 16:1 overall pressure ratio. The competition stands to 10, 11. A compressor which has two variable stator vanes, cooled blades for the high-pressure turbine, investing on material like single crystal, additive manufacturing, which is done next door to us in our new plant in Brindisi, which offers state-of-the-art in terms of design, optimizing weight, part count, and shape of the parts, but also in the control system. And here I think the control system is a very good example of the effect of a strong and effective cooperation between institution and industry. We developed 7 years ago from scratch, from the white sheet of paper, thanks to the collaboration between the Apulia region, the University of Bari, Polytechnic of Bari, and Avio Aero, a capability on designing, developing, and certifying the control system, the FEDEC, which represents the brain of the engine. And the FEDEC is something unique in this market class because control the engine and the propeller, offering an optimized solution across the entire flight envelope. And the result of all those technologies are simply value to our customers. Value in terms of performance, we are offering 20% lower fuel burn, 20%, 10% more power at altitude, lower emission, lower noise, lower maintenance cost. Therefore, giving our clients the possibility to have more powerful and performing airplanes. So despite the fact this engine, based on this performance, has been selected by one of the most important airframers in the world, which is Textron, for the new single-engine turboprop aircraft called Beechcraft Denali. The engine so far has accumulated more than 6,300 flight hours, on 30 engine assembled so far, and is going to the most rigorous certification process ever for a turboprop engine, which will be completed with the certification by the end of this year. So nice project, and what is interesting about this is despite the fact that this engine has been developed for the civil market, based on the latest technology we introduce, it also makes the engine the perfect fit for the military application. And this is why in 2022, Airbus Defence and Space selected us, Avio Aero and the Catalyst, to power the Eurodrone. And this happened after 5 intensive and challenging years of competition. So lasted the selection process with our neighbors and friends of Safran in France. So the key CTQs for an engine for a UV application, a make-class UV application, and hopefully Colonel Urbano can agree on this, are very straightforward. So an engine for a UAV, for a make-class UAV, must offer lower fuel burn, high performance across the flight envelope to be able to cope with different mission profile. It must have a very high reliability, and it must offer the possibility to extract power to support the increasing demanding of operation with multiple sensors and payload. And this is what the Catalyst allows to do, again, thanks to the technologies. Because the fact that we can save 20% of fuel burn means that we can increase, with the same payload, the mission time, or given the same mission time, increase in the payload capacity, which again is value that we are offering to the final end user. The fact that we have a FEDEC allows the prognostic and diagnostic capability, therefore, in somehow increasing the safety of the system, because without having the pilot in the loop, the FEDEC allows to have a more controlled operation. And of course, also in terms of noise, which is another important CTQs for a UAV, the FEDEC again allows to change and modify the RPM output, and therefore reducing, in some cases, the noise level for certain kind of operation. So again, I think this was a great example of how investing in technologies, initially starting from the civil application, can also find out a very good compromise in supporting the operational need of our armed forces and our customers around the globe. Thank you.
Thank you. Thank you, Mr. Paolo. Thank you. From the speech of Mr. Salvetti, we got an idea of what doesn't mean being a game changer. Sometimes to get into a new market, you cannot work on incremental innovation, but you need to start from scratch. And this is something that we, the industry, of course, learn also from defense, because since aeronautics born, I mean, defense is always, the military always push us forward and forward, new technology, new systems, and whatever. So sometimes it's need to, starting from scratch, to what? To answer to the pressure needs of the defense. And also we understand very well, in this case, what does it mean, the duality. So the engine was designed, realized for civil, but at a certain time, the same could be used for the defensing, for the military. And so this is the duality we were speaking about before. And also, I would like to also to stress the fact that Catalyst is also a project in which Apulia region worked, DTA worked in collaboration with the Polytechnic of Bari, and so this is something we, as Distretto Tecnologico Aerospaziale, we are proud of. This is for the engine speaking, but if I want to be curious about what is the state of art of aerostructure, well, Mr. Nicola Gallo can express much more better what, for instance, the Grottaglie plant of Leonardo is doing, and which are the projects, which are the scopes. And so, Nicola, please, thank you for being here.
Thank you very much for the invitation. It's a pleasure for Leonardo and also for me to be here to share our vision and our experience and try to understand together which will be the future of this kind of urban air mobility. Is something that we heard a lot of times these days. Okay, as we said every time, aeronautics is changing. It's something that is completely different from the past. We are moving from the airliner that we know very well, for example, Boeing 787, that is manufactured very close from here in Grottaglie plant. It's something unbelievable in terms of dimension, in terms of technology, and I hope that all of you in the future, you will have the possibility to visit the plant because it's something really amazing and very uncommon around the world because it's a unique place in which you can find something so great, something so technological. We are moving from airliner to something completely new that is called advanced air mobility. Advanced air mobility, like for example this one, that is a vertical aerospace vehicle. These new vehicles are completely different from the past, and there are some key characteristics of this kind of vehicle. For example, they are most of them fully electric to reduce noise, reduce also the impact and the emission because they have to fly on the cities. And they will have a completely different mission profile. So they have to take off and land like an helicopter and fly like an airplane. And for sure, they have to have also aerodynamical efficiency that need to be improved because they need to save as much as possible power gain from batteries. And batteries are at the moment very heavy and very big, and also the design of this kind of airplane needs to be very to pay more attention to the balancing of the masses due to the batteries, and for these reasons it's very important that the airplane will be overall efficient. Another key aspect of this kind of vehicle is also that they need lighter structure. For these reasons, composite material will be the top of the selection for this kind of on vehicle, and also they need to have impact resistance because every one of us will want to be fly safe on this kind of vehicle. But the most disruptive, I think, in this case, differences within the respect to the past is the production rate. We are passing from 100 to 200 per year. That is a very high rate for aeronautical industries, to 100 to 200 per month. As you can understand, it's a completely different process, completely different aspect. We need to redesign all our manufacturing process. We need to find new manufacturing process and materials that can allow us to support this kind of rate. The certification is another key aspect because the scenario is in continually movement, and it's important to be fast. As quick as possible, we need to implement changes that comes from new regulation, from new certification process on our airplanes. But in which way Leonardo is approaching to this challenge? For sure, looking at the background that we have that will help us to be in this challenge. First of all, the expertise in manufacturing composite and all in aeronautics, that is very important. It is a tradition of Leonardo. The participation in successful programs such as Boeing 787 that I told before, or Airbus A220, or the other program that gave us the right experience that can be used for this kind of new aspect. Investment in research and development, not only in products but also in technology, because at the moment we are using some technologies that was developed in the past and that are enabling for these new products. But also with the creation of Leonardo Labs, that are a corporate lab with we hire a lot of researchers from university to improve the quality of our our research to work on a low TRL project, but also the implementation of the HPC in high performance computing, one of the most powerful in Europe that will help us a lot also in the future. This gave us the possibility to be part, as we said before, on the project, the European Mail Air Pass, in which Leonardo will design and manufacture the 30-meter long wing that is something very incredible for this kind of drone, but also completed with successfully the delivery of vertical aerospace demo 2. This is a nice picture that we took in our plant in the occasion of the delivery of this fuselage. The future, you can also take a look on our stand, small pieces of this fuselage. But the important thing is that we redesign and manufacture this fuselage in only 7 months. That is a timing unbelievable for the aeronautics before. Thank you.
Thank you so much to Mr. Gallo. So, Leonardo, let me say I'm proud to say that in the Apulia region, a plant of Leonardo is working on the edge. So, advanced air mobility is changing at the aeronautics sector, and we are in. And so, this is something must be stressed. And also, what maybe I would like to stress also, and maybe to take after, is the spillovering that we are going to see from different industry sector. Let's say, until some years ago, aeronautics, aerospace were kind of bubble sector. Now we are seeing some relating spillovering with our other industry sectors, for instance, from the automotive sector. And this is something is changing. It's changing our industry, our sector, and we must be also, we must be in on this changing. We must be knowledge about, yes, we are aerospace guys, we are aerospace people working in aerospace, but also we need to have this shifting on other industries, and this is something important. Before we speak about some systems, the Italian Air Force show us some system, the Rapier, for instance, and so I have Mr. Schettini here that maybe can speak much more better about. Thank you.
Thank you, Chairman. Good morning to everyone. It's a very pleasure for me to participate to this panel to speak about Sky Eye System. I am Francesco Schettini, Technical Director and the Chief Operating Officer of Sky Eye Systems. Sky Eye System is an Italian player with aeronautical competencies for design, prototyping, and manufacturing a manned system in the class light with maximum takeoff weight of 150 kilograms. 4 pillars have been defined to pursue our mission. The first one is a specific know-how in all core technology required by an unmanned system, ranging from the electronic and software design to aerodynamic analysis and structural and aeroelastic optimization. The second is to have an highly qualified engineers and technicians with the relevant background in strong aeronautical program. The third is the aeronautical approach. Aeronautical approach to develop a manned system, even if our platform have reduced the size and weight. Finally, CES is located in Cascina, near Pisa, and has established a profitable network with the University of Pisa and Florence, research institution, and innovative startup in order to intercept the cutting-edge technology. The first product of the Rapier family is Rapier X25. It is composed of a fixed wing aircraft with a maximum takeoff weight of 25 kilograms, a ground control station with functionalities typical of a tactical system. It is composed by a station for pilot and a station for sensor operator. And the third part is a portable pneumatic launcher. It is a native aeronautical dual-use system for surveillance mission, such as ISR, anti-pollution, territorial control, targeting, and so on. It has been acquired by the Italian Air Force and the Italian Army. And the main feature of this system are that is ITAR-free, okay? It has a military type certification. It is very important for me to highlight that we have no restriction for highly populated areas. We have a proprietary and customizable flight software, in particular flight control system. It is based on a modular platform and that permits to develop new versions with reduced cost and time to market. In addition, we have the possibility to install on board multi-payload. For example, we have a version with electro-optical infrared gimbal coupled with a synthetic aperture radar that offer sensor fusion capability. Finally, concerning the civil certification, in this year we will cooperate with EASA to extend the military certification to the civil one. Thank you for attention.
Thank you. Thank you. This is what is the state of art for the Sky Eye system. Now, just to close the panel and to have this second round, we would like to understand in some keywords, in some key points, which are the future. What our partners see, our panelists see as the future. And so, for instance, to my question to the Colonel Pagliara, which is the future vision of the Italian Army?
All right. First thing first, the good news, I have no slides for this second round. The key point of the first part for the Italian Navy was that it took for a long time to get there. And now we have something that is already operational, the Scan Eagle, something that would be operational in a short time, like the Euro Plus, something else we're looking at what we still don't have. This is going to be our test bench, and we will use those unmanned aircraft systems in order to evaluate what we will need in the future. Right now, we have not such a clear idea, but I can say that the three key points of the future of an unmanned system on board of the ships are basically what we need right now. We need unmanned systems that are able to operate on board of the ships. It's an environment that is very challenging. We need aircrafts that are able to land and take off from a moving platform that is not going only forward, but it is also exposed to the sea, so it's pitching and rolling. We need a platform that is able to be integrated with a very complex electromagnetic bubble around the ship, because the ship has sensors all around, so it's difficult to get that integration done. So this is what we need now. This is what we will need in the future. Other than what we see in the unmanned systems right now, I have an envision that in the future, for sure, will increase our need to have systems that are able to interconnect with each other, with the other unmanned systems, with manned aircrafts, in order to team up between each other. We need to implement swarm of drones that are able to operate maybe by themselves with artificial intelligence. So the ship in the future, in our envision, will be a system of systems. Will control unmanned and manned aircrafts, but not only aircrafts, also unmanned surface vessels, also unmanned underwater vessels. This is what's going to happen in the future. So the industry maybe is not going to be talking with the Navy. Maybe we'll be talking with the ones that build the ship.
Sure.
And third thing, and for sure, something that is going to happen that we will need in the future to enlarge the envelope of the missions that we will give to the unmanned system. Right now, as I told you before, we do only ISR, intelligence, surveillance, reconnaissance. But I can clearly see that in the future we will need to use them also to protect the fleet with using them like suicide drones, what we call the loitering munitions, and maybe also to move parts from ship to ship, so air mobility.
Good. Thank you. Thank you. So this is the future for the Italian Army.
Okay, Michele.
Pointing.
Before to respond to your question, let me to say, because in the previous part of my speech, I didn't speak about our systems. So invite you and who we want to visit our stand where there are two of our devices. About the future perspectives, similar what to say the Comandante Pagliara, because we have to change the perspective of UAV, and the modern scenario imposes us to change this perspective. In fact, we have to work on two important disruptive and emerging technologies. AI, artificial intelligence, and autonomous systems. Why these two technologies? Because they are mature enough in a short, medium term horizon to have a potential effect in the battlefield. So the future for the army is to create, to have a multi-domain bubble, tactical bubble.
I think we are short in time, so I think they are not changing the PowerPoint.
But in this bubble, we want to interconnect our sensor, and the sensor are UAVs first of all, and we need to have high availability of sensor. First of all, UAVs. And we need a hard and strong mesh networks of sensor. And a sense of these mesh networks sure is also a UAV. To conclude, how the Army are developing this concept. We want to develop this concept to conduct robotic autonomous campaigns. For example, last year there was a campaign about the urban environment. This year, the robotic autonomous campaigns of the Army is distributed logistics, and we want to involve the industrial sector, private companies, in order to develop the new ideas and new technologies. And for this reason, we promote the what we call technological call, a day in which the private sector can
An open innovation approach,
show, show yes, new technology, show new equipment, and together to develop this new concept.
Good.
Because we consider that in the future, just the cooperation, the synergy between us and the private sector will be the key to overtake these new challenges.
It's the paramount to reach. Okay, perfect. So what is the future, the vision of the Italian Air Force, our Italian Air Force? Just some key points.
Thank you again, Michele. Please, Regia, can you set my second part? I just have 2 slides to show you more. Okay, that's good. So what I'm going to do now is I will run each one of these items in the list just to give you a very small insight of which one of these. And afterwards, in the second slide, we're going to see the future. And when I will talk about the future, I'm talking about looking forward like 10 years, 20 years from now. On your right-hand side, you can see the trends for mini, micro, and light system. On your left-hand side, you can see the trends for mail or AIL systems. And if you see close enough, I mean, they are pretty much similar. Of course, the UAS evolution has been driven and is driven by emerging technologies. And today, the artificial intelligence is the one that is leading future and actually capabilities. So what we ask, to the industry, what we do need as users, it is a higher level of automation in order to conduct an autonomous mission when we talk about mail and AIL capabilities. So higher level of automation is the first trend. The second trend, of course, talking about artificial intelligence, we look forward to see more automatic takeoff and landing systems, and also for mini, micro, and light system, vertical takeoff and landing. Secure data link, of course, when we operate this system in a contested environment, we do need secure link. When we talk about secure link, I'm talking about robust and jamming-resistant protocol. Also, we look forward for more beyond line of sight link option. Talking about satellite in short band, wide band, the use of the 4G, 5G options built on these new systems. Avio was talking about before performance. We look forward for more a longer endurance, a longer range, which allow us for a downsides of the system, maybe can have more fuel. And what we look more is a very small logistics. We don't need anymore, a big logistics. We do need and we look forward for a very small logistics, both for mail and for mini micro systems. We talk about propulsion, many kind of propulsion, hybrid, 100% electric fuel. We still do need heavy fuel for Navy, because Navy, the operational requirement for Navy, it is about heavy fuel, so we do need to keep working on that. Airspace integration, we have been talking about yesterday, today, about the need of have on board systems, the capability in order to integrate the system with the unmanned system, with the manned system together in an integrated airspace. The payload, as far as the payload is concerned, we would like to have a modular payload, so system that we can change, that changeable payload. And also the workload inside the ground control station, so system that ensure a lower workload for the pilot and for the sensor operator, and also a very short training. Because the Ukraine war, the experience from Ukraine lead us toward be ready. So we don't need longer training, we need a very short training. So the systems must be capable and easy enough, the interface, to allow this short training. And how about the range of operations? So far, we've been experiencing ISR type mission, so intelligence, surveillance, and reconnaissance mission. And if we talk about in a dual use scenario, I'm speaking about maritime patrol, anti-pollution, coastal guard, security, public order. If we move toward a more military scope, we'll talk about ISR, target acquisition, fire support, support to force protection, support to special operations. But now, we are with the Ukraine war, we are moving forward, looking for fire capabilities. And not only, we are talking about yesterday and today about air transport, also about air-to-air refueling and medical evacuation, transporting good and dangerous good. So those are, the application that we are moving on in the future. But what is the real future when we talk about tomorrow, 20 years from now or 10 years from now? It is something that we call MAMT concept, manned teaming concept. You can imagine something like at least a single manned platform with a loyal wingman, cooperative drones. Loyal wingman that is basically a surrogate of the normal wingman, the man wingman. So this loyal wingman, it is basically a force multiplier because it can carry out, more fuel for the man one, more ammunition for the man one, and it is also a multi-role because with an high-level tasking coming from the pilot, tasking the system, the loyal wingman can be sent for a deep attack, for a deep ISR, for decoy. It can be itself a defense counter-mission system. Of course, the loyal wingman, it is expendable. It is expendable because it is cheap, must be cheap. We don't want system to be too much expensive because they must be expendable. And they are expendable as well because there is no human on board. So this is, of course, we are talking about a revolutionary type of mission. It is an autonomous mission with a high level of automation for aviation, navigation, formation. So this is what we see, how we see the future. Cooperative system, high level tasking, high level of automation, and something that we can expand. Because there is no human on board, and because that's cheap. That's how we see the future. So please, I'm open to any questions. Please have a look on our Rapier X25 out there, and feel free to come inside. Thank you very much.
Thank you so much. Just a deal with the civil, since we are civil. Just one word, Avio, which is the future. One word. A shot.
One word is efficiency, fuel efficiency, and reduction of CO2 emission. So Aviario is fully committed for the future to develop those technologies which allow our engine to be much more fuel efficient and therefore in line with the industry target to be net zero CO2 emission by 2050. And this is what Aviario is doing. Today we are leading a consortium of 51 entities in Europe between industry, research center, and university to study the hybrid electric technology coupled with hydrogen fuel cell. So this is our priority today, and this is the way we want to shape our future in a sustainable way.
So,
thank you.
Fuel cell, hydrogen and fuel cell. Leonardo, one word.
Okay, I can say improving on manufacturing process and research, and also sustainability. There are the two main pillars through different technologies that we can discuss later.
Together, okay. Sustainability. One word, Sky Eye System.
Okay, our technological roadmap identify 4 targets. VTOL technology in classical way and innovative way. navigation in GNS denied environment, and a long time perspective is the introduction of hydrogen fuel cell to a more
That's
electric system. Thank you.
So, thank you to my panelists. Thank you, Mr. Schettini. Thank you, Mr. Gallo. Thank you, Mr. Salvetti. Colonel Urbano, Colonel Russo, Colonel Pagliara, thank you so much.